Just seen from the previous example, and I'm hoping that you're walking away with some sense. If our function is positive, it remains positive. If my function turns negative, that is the place where I must reflect it. Now, critical points on an absolute value must be the zeros. In fact, if you take a look, this is where my function changes behavior. Now, you'll be taking a look at this more in depth next year. So I'm going to first start us off here, and I'm going to challenge you to write the piecewise function here. Try to make a quick sketch of the graph. Now remember what I just said, the critical points are the zeros. So let's find the zeros. All right, thanks for joining me back. You found the zeros, I'm hoping. If not, press pause now and do it. All right, so I know, just gleaning some very superficial information here. I know that this is my function without absolute value. This is an upward opening parabola. And what I'm really interested in is not the vertex, but rather the zeros, because I'm writing it as a piecewise function. So naturally, I'm going to find the zeros of this. So I'm just going to say maybe, just maybe, we could have a few scenarios. This is an upward opening parabola. We could have 1, 0. We could have no zeros, which would be an interesting thing. Interesting but trivial at the same time. Or we could have 2 zeros. So when we find the zeros, the function, we have to equate y is equal to 0. So I do that. I do the quadratic formula, I plug it in, and what I get is that I have 2 zeros at 2 plus or minus the root of 6. Now for here, some of you guys may be wondering, I'm going to lose some of you from this step to this step, no doubt. But you've tried this on your own. And really this is 4 plus or minus 2 root 6 over 2. You factor out the common factor of 4, a factor of 4 from 24, since it's a perfect square, and take the square. Divide both top and bottom by 2. All right, getting back, there we are. So very quickly, this goes up. I'm not even going to put the Cartesian axis. I'm only going to put the x-axis there. And I know that I have a 0 at, now look at my answers here. I have 1, 0 at 2 minus root 6, and 1, 0 at 2 plus root 6. So in other words, I guess very quickly, if you want, press pause, write this as a piecewise function. I notice that my function, I'm going to call it my leftmost arm. My leftmost arm here is positive. So the function still stays as x squared minus 4x minus 2. For what x values? For all x's less than 2 minus root 6. For all of these x's, right? And this is the x value that is exactly negative 2 minus root 6. Now in the middle here, we're going to have to reflect this thing. So let's simply put a negative sign in front to indicate that I've reflected it. In what domain? Well, in between these two x values. So there's my green graph. I'll make that up. And now I just have to worry about that last arm. If you notice, the last arm, or the value of our function, is positive, so it's going to remain positive. So there's no operation to be done to the set of instructions for my function. There. It's a piecewise function. On the leftmost arm, it remains the same. That was the domain. In the middle part, we had to reflect it. And what are the x values for those x values? The rightmost arm, that is my function, that is the domain. All right, let's go to the last question. All right. So we can also construct the absolute value using transformations. And this idea of transformations is so important that in grade 12 you actually spend a whole entire unit on it. If the parent function is f of x and has point xy, then the absolute value function, y is equal to the absolute of f of x, has point x comma absolute value of y. So this is a mistake. I'm sorry, I'll just scribble this out. So in other words, if I have point xy on f of x, and which is incidentally what I gave you, I have to change that to point comma x comma the absolute value of y. But I'm transforming the graph. So we're going to graph y is equal to the absolute value of x squared plus 4x. But really we're just going to be using a lot of much is the same. If my function is positive, it remains positive. There it is. So if you want, you could say negative 5, 5 remains at negative 5, 5. Now in the middle here is what I'm interested in. I see a point right there, and right there. That's negative 3, negative 3. On the absolute value function, it changes to negative 3, 3. This is negative 2, negative 4. On the absolute value function, it changes to negative 2, 4. That is, you just take the absolute value of the y, so it's all the way up there. Now on this third point, we have negative 1, negative 3. That changes to negative 1, 3. Now, so it looks like I have a graph right there, but we're missing two critical points, arguably the most important points, negative 4, 0. And negative 4, 0 remains at negative 4, 0, but it enables me to know that that's a point. Similarly, 0, 0 will remain at 0, 0. So my graph now is this. My right arm remains the same since my function is positive. I wish you luck in your endeavors here today. If you have any questions, feel free, reach out, let me know.